Hi, everybody. My name is John Handler. I'm a solutions architect with AWS, and I cover our OpenSearch and service and the open source project. Today, we're going to talk about reliability and uptime and how to build observability with various solutions. So let's start out by talking about what is observability. So observability is collecting, analyzing, data from applications so you can understand what the issues are, get alerts for those issues, troubleshoot those issues, and resolve those issues. Observability really refers to the collection of instrumentation and other metric data around your application that enables you to solve these issues. So why do we really need observability? Well, anytime we're building some kind of software solution, there are various problems that you're going to have. There's denial of service, service outages, cost overruns, component dependencies, networking connectivity, all kinds of challenges that you're going to face. Ultimately, those are going to lead to downtime for your application, for your end users, for your customers, and really, there's a cost to that to your business. Not only is there a financial cost, which can be as much as $80,000 to $100,000 a day, there's also a cost in fatigue for your developers, in loss of trust with your customers, and eventually this downtime is going to lead to poor business outcomes. So what are the goals for doing observability? You really want to improve the overall end user experience for your applications and services. And observability is the suite of tools and the data you use to provide that better experience. Getting specific, observability really rests on three different kinds of information. The first information is log information. Anybody who's ever done any debugging knows that when something goes wrong, the first thing you need to do is go look at the logs. The logs have the information that lets you know what happened during the execution of the application that ended up causing the problem. The second kind of data is metrics. Metrics give you the ability to monitor what's going on, how your application is performing, and with trend analysis, or to be able to predict and find trends that will let you know that you're headed in a poor direction. Traces are logs that are produced from your application that capture the course of the processing of a single event through your system. And with these three kinds of information, you can go in and figure out exactly what's going on. We have a number of managed services that address these various concerns, and we're going to go into depth on all of them. You really want to ultimately influence and improve both your operational and your business outcomes. So on the operational side, by employing these tools to look at the information, you'll achieve better visibility into the underlying functioning of your application. This is going to enable you to troubleshoot problems in near real time. Many of these systems, most of these systems, can flow data in near real time. They can alert you when problems are occurring or when problems hopefully are about to occur. And you can go in and use these tools to look at your log data, to look at your traces, to look at your timing, and to figure out what it is that you need to fix. On the business side, observability is going to give you a more resilient application. By using these tools, you'll be able to build out your applications in a better way and keep them up and running longer. End goal, as I said, is to improve customer experience. So your application is serving whatever business need you have, and keeping your customers happy by running a low latency, low error rate, seamless kind of application will ultimately give your customers the best experience. We have a number of different workloads and use cases where observability is really emerging as a very important tool. Microservices and containers, and especially the move to a service-oriented architecture, is driving a lot of need to understand how your application is performing and how your services are performing within that application. So we see a lot of usage in the microservices architecture. We also see a lot of use cases around digital experience monitoring. So when you have a web or a mobile application that is providing some service to your end users, you want to be able to dig in and understand what are the dependencies and how is it working. On the operational side, and of course, observability really flows out of the DevOps kind of methodology. So when we're looking at an operational situation, observability is really going to, again, help you dig in, troubleshoot, and fix issues. And finally, looking at data lakes enables you to understand how your information is flowing in and how it's related to one another. So on the mechanics with observability, it enables you, again, to detect when either issues are happening or issues are about to happen so that you can investigate. And investigate here is a kind of broader bucket where even if it's not a real-time problem that's happening, you still have the ability to dig in and figure out over the past what has happened in order to remedy and improve your software. And finally, again, remediating and improving the software is one of the ultimate goals. So to be able to remediate issues and bring back that high quality user experience. So this is a complicated question. Is there one observability tool to rule them all? Sadly, the answer is no. At the moment, this is an emerging segment, and we're seeing many different technologies that enable this observability kind of use case where there are competing possibilities, a lot of different, both AWS services and open source technologies that give you the fundamental capabilities that you're looking for, but you need a way to pick a single choice to go forward. We're going to review all of the different tools that are out there and try and highlight some of the pros and cons to help you make that decision. At a high level, what you need to accomplish with observability is really an end-to-end pipeline that's going to start out with instrumentation to pull or collect the logs, metrics, and traces into a single stream. That stream, you're going to ingest that stream into some kind of collection and storage layer, and then that storage layer can employ monitoring and alerting for real-time interaction with the underlying data. But you also want to be able to search and index that data in order to go and find the problems that you're having. And then finally, we end up with a visualization layer where you can build dashboards that enable you to correlate data that's coming in through this pipeline and also figure out what's going on. Peeling back the onion just a tiny bit, we have a number of our different technologies here. So on the instrumentation side, we have our CloudWatch agent, we have an X-Ray agent, we have AWS distro for OpenTelemetry. We also have FluentBit that enables you, again, to pull in those data sources and start to work with them. Of course, if we have data in CloudWatch, there's Amazon CloudWatch Service Lens that enables you to get container insights, Lambda insights, a bunch of contributor insights, and other synthetic kind of data. In the collection and storage layer, we have CloudWatch Metrics, CloudWatch Logs, X-Ray, Prometheus and managed service for Prometheus, as well as Amazon OpenSearch Service. So these are kind of the containers where you can flow this data. On the dashboarding side, then, we have Grafana and Amazon Managed Grafana, as well as OpenSearch dashboards that enable you to build visualizations and dig in with service maps and trace graphs and the more richer kind of experiences around this data. So let's talk through some of the open source alternatives. First of these we're going to talk about is OpenSearch and OpenSearch dashboards. OpenSearch is a community-driven open source search and analytics suite. It's derived from Apache 2.0 licensed Elasticsearch 7.10.2 and Kibana. The OpenSearch project is really the way that we are carrying forward that core search and analytics capability into the open source world. The project itself consists of OpenSearch, which is a search engine and visualization engine, as well as OpenSearch dashboards, which is a UI and visualization layer, and includes plugins that enable things like alerting, anomaly detection, deep level of security, a bunch of different functionality that's provided by those plugins. It enables you to ingest your data, you can secure it, and analyze it with aggregations, view it, and bring all the logs, metrics, and traces into one place. It does have an observability suite that's built into it, along with anomaly detection and alerting, as I mentioned, and this enables you to identify and react to issues in your solutions. Prometheus, also community-driven open source. It's a systems monitoring and alerting toolkit. It collects and stores metrics primarily. They are time series, and they have key value pairs called labels that enable you to bring those metrics in. It has a server where it's going to store that data, an alert manager and a push gateway to facilitate viewing and working with that data. Usually you will handle visualizations with Grafana. It really, again, is more on the metric side. So it enables you to gain insights from numeric measurements. So this is stuff like your CPUs, your latencies, etc. Grafana is a visualization tool that is, again, community-driven, open source. It's an analytics platform. You can query your data, visualize your data, alert on your data in order to understand what's going on with your metrics, logs, and traces. It does connect to many different backends. So the data source plugins enable you to connect to things like MongoDB, Dynatrace, ServiceNow, Amazon OpenSearch Service, a lot of different Prometheus, a lot of different backends that you can connect it to. You can define alert rules. So again, alerting is a key capability within the observability stack. You want to be able to send out alerts when things go wrong. With Grafana, you can send alerts to places like Slack, PagerDuty, and Opsgenie. You can also work with different time ranges. That gives you the ability to kind of drill in and understand now versus then. So one of the foundational elements of observability is the OpenTelemetry standard and the OpenTelemetry stack. It's an open source project designed for the creation and management of telemetry data, such as traces, metrics, and logs. It does support a lot of wire formats, Jaeger, Zipkin, and Prometheus. This enables you to bring that data in and bring it into a common format. It's an evolving project, a lot of different people contributing to it, and we currently have, we'll get to the Amazon distribution for OpenTelemetry, which brings it into a more managed situation. Currently works with traces and working on metrics and logs, but not entirely there yet. FluentBit is in the collection layer. Again, this is the instrumentation, also open source, very fast, lightweight, scalable, forwards logs metrics from their sources. It has a plugin-based ecosystem that enables you to collect and filter and transform and augment your data. It is true open source, so it's vendor agnostic and really comes as a derivative of FluentD. Integrates with Prometheus and OpenSearch, Amazon CloudWatch, Amazon X-Ray, Amazon S3, a lot of different destinations where you can send this data and forward it on. In the OpenSearch project, we have Data Prepper. Data Prepper is in the collection and transformation. So it's also open source and it processes observability data. So it gives you features that enable you to filter and enrich and transform the data that's coming through the pipe and enable downstream analytics and visualization. It right now supports the processing of distributed trace data, log ingestion, and is moving towards supporting metric data in the future. Also integrates with Jaeger, Zipkin, OpenTelemetry, and FluentBit. So we're going to take all of those pieces and build them into one example architecture that is an open source focused architecture. On the collection side, we have our OpenTelemetry collector that's going to bring in traces and get those to Data Prepper, which is going to prepare them. We also have FluentBit collecting metrics and bringing those into Data Prepper. FluentBit also can tail and collect log data, which is going to flow directly to OpenSearch. So we have these two pathways that come into OpenSearch, the Data Prepper pathway for traces and metrics, logs flowing from FluentBit directly to OpenSearch. We can also take metrics out to Prometheus from FluentBit for our metric evaluation. On the visualization side, then OpenSearch dashboards will connect with OpenSearch and enable you to build visualizations and employ the more rich experience within OpenSearch, specifically around traces and log data. We can use Grafana to connect both to OpenSearch and Prometheus, and that gives us an additional ability to bring that metric data into the same location visually as the log and trace data. So we've gone through a number of the different open source alternatives. Many of those have a managed solution within AWS that will make it easier to deploy and run and operate those observability components. First of those we'll talk about is Amazon Managed Service for Prometheus. It's Prometheus compatible. It's a monitoring and alerting service. And again, you use it for monitoring containerized applications and infrastructure at scale. It automatically scales for ingestion and storage and alerting and querying of the metrics as your workload grows or shrinks. It's integrated with Amazon EKS, Elastic Kubernetes Service, Elastic Container Service, and AWS Distro for OpenTelemetry. We said a little bit about Amazon OpenSearch Service, but Amazon OpenSearch Service is a managed service that makes it easy to deploy, operate, and scale OpenSearch and legacy Elasticsearch clusters in the AWS cloud. It has some built-in observability tooling with a trace analytics panel, an event analytics panel, and a log analytics panel. It also comes with anomaly detection features that automatically learn the normal behavior of your system and can generate alerts when that behavior leaves the normal. It's integrated with Kinesis Data Firehose, CloudWatch logs, and other tooling. Service Lens it enables you to run observability on top of your CloudWatch data, integrate traces, metrics, logs, and alarms into one place. It integrates CloudWatch with AWS X-Ray also to provide an end-to-end service map and view of your application. You can do correlation against Lambda functions, API gateways, Java applications, and either container or on EC2. Amazon Managed Grafana is a secure, production-ready, open-source distribution supported by AWS. We developed it in collaboration with Grafana Labs, and it enables you to connect to data sources like Amazon OpenSearch Service, Amazon Managed Service for Prometheus, X-Ray, CloudWatch, TimeStream. It has security built in and enables you to connect securely with all of these data sources in a way that preserves their integrity. There are some pre-built dashboards that give you faster access to the insights that you're looking for. AWS X-Ray collects data about requests that your application serves and gives you tools to view and gain insights into that data. X-Ray receives traces from your application in addition to AWS services like AWS Lambda that enable you to bring that trace data in and view service maps and trace graphs and the other tools that you're used to. Amazon OpenSearch Service is a managed service that enables you to deploy, scale, and operate OpenSearch within the AWS cloud. It supports OpenSearch versions 1.0 and 1.1 as of today, as well as legacy Elasticsearch versions from 1.5 to 7.10, with visualization capabilities provided by OpenSearch dashboards and Kibana for the 1.5 to 7.10 versions. Finally, we'll talk a little bit about AWS Distro for OpenTelemetry. Secure, production-ready, AWS-supported distribution of the OpenTelemetry project. It is backed by AWS support and gives you one-click deploy for ECS and from the ECS and Lambda consoles. There are exporters that enable monitoring solutions like AMP, Amazon Managed Service for Prometheus, CloudWatch, X-Ray, OpenSearch Service, and other third-party solutions. We're going to dig in just a touch on Amazon OpenSearch Service just to give you a feel for some of the specifics around what observability looks like in practice. So again, we have our logs, metrics, and traces. We're going to look at first logs. So within Amazon OpenSearch Service and from OpenSearch dashboards, you can do all kinds of visualizations that enable you, first of all, to see in aggregate what's happening. We have live tailing of the logs, including surrounding events. So this enables you to dig in and really look at the logs and figure out, okay, here's some kind of gross statistics about what's happening, and here are some specific log lines. You know, OpenSearch is ultimately a search engine. I can search for my errors. I can look at what's going on and what's happening around that in my log files in a time-based kind of way. Amazon OpenSearch Service and OpenSearch Dashboard provides a complete sort of trace analytics experience. And when we talk about, sort of trace analytics, there are a couple of major components that we see. The first of those is trace spans. Again, traces provide that end-to-end view of the processing of a request within your system. They're all connected together by a single trace ID. So a request comes in, it's assigned a trace ID. You carry that trace ID through your software, instrumenting with calls to send out that trace data or log that trace data, all again based on that trace. So with this, you can get a hierarchical view of the processing of your request, and especially the latencies and any errors that occurred in the processing of that request. This enables you to really drill in and figure out, where is the time going in my application? Is my database very slow? Or perhaps there's a particular code section that is taking most of my latency. That gives you the opportunity to dig in and really look at that piece of code to figure out where the bottleneck is and really to remediate that. Your service map gives you a higher level view that's an end-to-end view of all of the microservices that you've touched in the processing of your requests. Again, this all aggregates up so you get a view of where is the latency going. Again, if there are errors, they'll show up here. So this lets you look at your components, figure out how they're connected, and figure out, the dependencies and where there might be a challenge with latency around those dependencies. And finally, you have trace groups. Trace groups enable you to bring trace information into a grouped format around particular activities in the application. So this way you can, again, look at and figure out where is the latency going and where do I need to figure out and fix something. We recently have added application analytics. This enables you to build application views across log, trace, and metric data. You select log sources or trace groups or services to be part of an application. It enables you to monitor availability and drill into detailed views on the traces and service logs. This gives you, again, with Span ID and Trace ID, you can trace into what's going on and figure out any issues that you're having. One of the features that's a kind of sideways feature, but super useful, with OpenSearch dashboards, we support a feature called notebooks. Notebooks are documents that enable you to put cards onto that document to bring all kinds of different information together and really tell a story about a particular event or something that happened. You can export those as PDFs or PNGs, and you can share them around and enable everybody to know what's going on. With OpenSearch and Amazon OpenSearch Service, we provide machine learning kind of innovations. And chief amongst these, and especially within the observability space, is our streaming anomaly detection. With streaming anomaly detection, the system will automatically learn the correct behavior or the normal behavior of a metric that you're sending in, a metric or metrics. It uses random cut forest to predict when things are going off the rails, and it is integrated with alerting to send you alerts when things like your CPU is suddenly spiking or your traffic is suddenly spiking. It brings that information to you. Recent improvement enables you to basically collect or group by categories within your data. So the typical use case for this would be if you're running 1,000 servers and you want to look at the CPU utilization of, you actually want to group that down by the host so that you can see if there's a particular host that's exhibiting anomalous behavior, you can get an alert for that specific host. Just a quick pass at sort of how all of this would work in a container service. But you have your VPC with your availability zones. You have your users sending application traffic in via a load balancer. It's really all hitting your Kubernetes application, which potentially is running with Amazon RDS as a database layer. You're going to use, whether it's the OTel collector or FluentBit or one of the other architectures, to bring that data out to manage service for Grafana, manage Prometheus, Amazon OpenSearch Service, and then use Grafana for dashboarding or OpenSearch dashboards for dashboarding. Just looking at a little bit deeper, we have our metrics, traces, and logs. Within the worker node, then we have our application pod and container. The FluentBit is going to tail standard out and standard error. I'm going to forward that to Amazon OpenSearch Service. We have our OTel collector container. OTel is OpenTelemetry. That is going to send metrics and traces off to Prometheus as well as Amazon OpenSearch Service. In the prior diagram, I had a box that said buffering and delivery. I wanted to share one of our more cost-efficient and good architectures in terms of bringing that data across. So if you have either FluentD or FluentBit, we generally would look at S3 as a staging area where you're sending all of your metrics, traces, and logs. You can trigger off of the bucket notification and use a Lambda to queue up the object create into SQS. We then have a Lambda that's going to pull the original object, parse it, and prepare it to deliver to Amazon OpenSearch Service using the Bulk API. This is a very common pattern that we use. It is both, again, cost efficient. It gives you basically a backup of all of your data, exists in S3, so that makes it easy to replay or work with other tools like Athena. And this enables you to, again, keep that data over the long term at low cost. So 3 takeaways here. Observability really is going to allow you to measure and monitor the behavior of your applications and infrastructure. And the end goal of all of this observability is, again, to bring a better end user experience for better business outcomes for your software. We have open source. We have open source technologies across the board, also powered by AWS in many cases, that enable you to measure and monitor this behavior. How can we help? Please learn more, look at our OpenSearch Service free trial, and love to hear about what you do. Thanks very much for your time and attention today. Really appreciate it.